Good evening, everyone. Today we will be learning about hydrocarbons. So, if we define hydrocarbon, then we will say that hydrocarbons are those substances which are having carbon and hydrogen only. For example, methane, ethane, propane, butane, hexane, heptane, etc. etc. Let us talk about types of hydrocarbon. There are two types based on single bond, double bond, and triple bond. First one is saturated hydrocarbon, and second one is unsaturated hydrocarbon. Let's talk about saturated hydrocarbons. So there are those hydrocarbons having single bond between carbon atoms. There are they are also known as alkane, and its general formula is CnH2n plus 2, where N indicates the number of carbon atoms, and it is not very reactive. Now let's write the name of hydrocarbon. For single bond, we will use N, and if hydrocarbon has one carbon atom, then we will say methane. In the same way, for two carbon atom, we will use H. So the name of C2H6 will be ethane. In the same way, we can write propane for 3 carbon atom and butane for 4 carbon atom and pentane for the 5 carbon atom. Let's talk about unsaturated hydrocarbon. We have two types of unsaturated hydrocarbon. First one is alkene, a hydrocarbon with at least one double bond is considered as alkene. And secondly, a hydrocarbon at least one triple bond considered as alkyne. Let's talk about alkene. The general formula of alkene is CnH2n. Let's look at some examples. As you know, for two carbon atom we will use H. For three carbon atom we use Pro. For four carbon atom we will use But, and double bond will be used E. Hence, we will name C2H4 as ethane. For C3H6 will be called propene, and for C4H6 will be called butene. Let us talk about alkyne, a hydrocarbon in which at least two carbon atoms are connected by triple bond. Then we will call those hydrocarbons alkynes. So their general formula is CnH2n minus 2. If we talk about reactivity, they are more reactive than saturated hydrocarbon. Let's talk about some examples. C2H2 will be called as ethyne because it has triple bonds, so the suffix will be used "-ine". For two carbon atom, we will use H, and for C3H4, its name will be propane, and for C4H6, its name will be butane. Now let's draw the structure of alkane. As we know that carbon has valency which is equal to 4, and these valencies are satisfied by hydrogen. So here is the structure of methane, ethane, propane, butane, pentane, and hexane. Let us summarize this. If we talk about alkane, they are saturated hydrocarbon, and its general formula is CnH2n plus 2, and they form single covalent bond, and suffix will be "n". If we can see in methane. Now talk about alkene. They are unsaturated hydrocarbon having general formula CnH2n, and is and they form double carbon bond between carbon atom, and suffix will be used "-ene". As we can see in ethyne. Now let's talk about alkynes. They are unsaturated hydrocarbon. Their general formula is CnH2n minus 2, and they form triple bond between two carbon atoms, and suffix will be used "-ine". As as you can see in ethane. Now let us talk about isomers. Isomers are those hydrocarbons which are having same chemical formula but different physical structure. For example, butane with chemical formula C4H10. It has two isomers. First is N-butane and second one is isobutane. So you can see structure on the slide on your screen. Now let us talk about homologous series. So homologous series is the series of hydrocarbons which has general formula, similar chemical properties but different physical properties. The adjacent member differ in molecular formula YCH2. So here are the some characteristics of homologous series. First one is all members can be represented by the same general formula. Second one is any two adjacent homologous differ by one carbon atom and two hydrogen atom in the same molecular formula. All compounds of a homologous series show similar chemical properties. Their physical properties such as melting point, boiling point, density, etc. increase the increasing molecular mass. Let us solve one more question. A group of organic compounds having similar structure and similar chemical properties in which successive compounds differ by CH2 group is called isomerism, homologous series, structural isomerism. The option is none of the above. We have learned in the previous slide. This is the definition of homologous series. So, this is your answer. Here is the end of the class and see you on tomorrow. Bye bye.